How can we capture high-quality, high-resolution TEM micrographs of powdered samples, ensuring that individual particles are well dispersed rather than aggregated? Achieving a clear, interpretable image starts long before the sample enters the microscope. It begins at the bench. To master this process, you will need a few essential laboratory tools: the appropriate dispersant, a suitable TEM grid, an ultrasonic bath, precision tweezers, and high-quality micropipettes. The first critical step is selecting the right dispersant. You might see people refer to these as solvents, but in the context of TEM preparation, the term dispersant is far more accurate. The goal is not to dissolve your powder, which would destroy the morphology you intend to study, but rather to create a stable suspension. Think of it like sand particles suspended in water. The medium simply acts as a vehicle to separate the particles. By achieving a uniform suspension, you significantly increase the probability of observing isolated, individual nanoparticles on the grid once the medium evaporates. Next, let's talk about concentration, a decisive factor in the success of your imaging. If your suspension is too concentrated, you will inevitably face severe agglomeration under the beam, which drastically degrades image quality and obscures structural details. Conversely, if the concentration is too low, you'll find yourself wasting valuable microscope time searching for a single particle on the grid. Always consult peer-reviewed literature for the optimal concentration ranges specific to your material. The procedure itself is straightforward but demands precision. First, weigh your sample using a calibrated analytical balance and transfer it into a microtube. Add the appropriate dispersant to create your suspension. Now, place the microtube into an ultrasonic bath. This is where the physical dispersion happens. I want to emphasize that the ultrasonic power and sonication duration are variables that dictate your final result. We will dive deeper into the physics of sonication in a future video, but for now, remember, excessive sonication can damage the delicate morphology of your particles or induce thermal instability. Insufficient sonication, on the other hand, leaves you with persistent clusters. Calibration is key. Once your suspension is ready, use a micropipette to carefully deposit a few droplets onto your TEM grid. Allow it to air dry in a dust-free environment, preferably a clean bench or a desiccator. I strongly advise against using ovens or external dryers, as they can induce unwanted reactions or surface defects in sensitive samples. Furthermore, ensure the grid is thoroughly dried. Residual dispersant can outgas inside the TEM, compromising the column's vacuum and potentially contaminating the system. Finally, mount your dried grid into the TEM specimen holder, and you are ready for imaging. Have you encountered specific challenges while preparing TEM samples? Do you have a go-to protocol for difficult powders? Share your experiences in the comments below. I'd love to hear how you approach these technical hurdles.